So today we're going to be looking at operational amplifiers, or op-amps. They're active elements that supply energy and exhibit both linear and non-linear behavior, and we're going to use them to perform some mathematical operations. Specifically, we'll be looking at homework 8, question number 2, which is an op-amp, and we're going to have to find V0 and I0. So let's begin. So looking at the circuit, the first thing we need to do is understand some givens in the circuit. So what we do know is that IN and IP, which are the currents going into our operational amplifier, are equivalent, as well as VN and V0, and IN and IP are always 0. So we need to remember that before we go into this problem. So now we have to consider the various currents that are flowing out of our node. So we have the current going through the 4K ohm resistor as well as the 12 voltage source. We have negative 2 milliamps coming in. We have I0 going out, and then we have the current going through the 3K ohm resistor and the V0 source. So we have to consider these these currents. So here's the equation. We have Vn minus 12 over 4 minus 2 milliamps plus Vn minus V0 over 3 plus In equals 0. We did KCL, so we're going to go through with this. But wait, what do we know? We know that Vp equals Vn. Vp is the same as our ground source. It's only connected to that, which means Vn is also our ground source, which means that Vp equals Vn equals 0. Remember that, Vn equals 0. So then we put Vn as 0, and we continue with our calculations, also noting that In is also equal to 0, it's always equal to 0. So we continue our calculations down to find that V0 is equivalent to negative 15 volts. So that's one of the answers that we needed. Keep that down. Okay, so now we have to find I0, so we have to understand the currents that are going out of V0. So we have the current going through the 3K ohm resistor and the current going through the 6K ohm resistor, and then I0, which is also coming out. So we have to consider these separate currents to find our I0. What's I0? We need to find the currents through the 3K ohm and the 6K ohm resistors to find out. So we use Ohm's law in both cases to get negative 5 milliamps and negative 2.5 milliamps. So using these current values, we can do KCL at V0 to get negative 5 minus 2.5 plus I0 equals 0. So I0 equals 7.5 milliamps. So there you have it. Our final answer is that V0 is negative 15 volts and I0 is 7.5 milliamps. Thank you.